don't need, please leave them in the cooling section of the flow prep. First, we're going to take whatever tube with its appropriate quart. We're going to weigh it empty. And we're going to record that mass. Most of our test tubes weigh about 40 grams when they are empty with a quart. Because these test tubes are so large, I tend to ignore the very last digit on our scale here. We have issues with static as well as with airflow because the top is open right here. Because of that, the last digit tends to vary somewhat. So I like to just report the 3 decimal places, the 3 places after the decimal, instead of reporting all of them. Now that I have the dry weight of my, assembly weight, that is called the assembly weight of my sample, I am going to fill this up with my material. Now there are a couple different ways you can do it. If your material is not very staticky, you can just pull a spatula out of the drawer underneath the scale. You can use a large spatula or one of our smaller spatulas, and you can just scoop the material in there. You also use a weigh paper, which we have a box of weigh papers right here. Fold that up into a funnel or kind of a curled shape like this. And you can put that in the top like that to pour your material in. If you have something that has issues with static, that is particularly staticky, because we're putting this into a glass test tube, that can exacerbate the problem. So we have these little funnels right here. This sits on top of the test tube right here, and you can pour your sample in this way. This is a little bit harder to clean because of the stuff in the bottom here. You can see there are different kind of layers to the bottom here. So this can be a little harder to clean if you're prepping multiple samples at once. But this is a good method if you're going to have issues with static. This can help dissipate some of that static. For my sample, I'm just going to use a weigh paper. And I am going to put down a big Kim wipe here so that I'm not getting powder on the table. And you're going to aim for about 1 gram of material. This does not have to be exact. We're going to weigh it so that you do know exactly how much material you have. But aim for about 1 gram of powder. There we go. So you can see I've got my powder in here. Some powders will stick to the glass. If that's the case, you want to make sure that this region is clean so that you don't get any residue on the cork. And also when we put it into the machine, we will have a little insert called a filler rod that's going to go right here. Any material right here will not be tested. And so its mass could potentially throw off the results if you're looking for really, really minute details. For most cases, it's not going to make a huge deal if you have a little bit of powder here, but try to keep this area clean if you can in the test tube. So now we're going to take a second weight. That's going to be called, that's what I call the wet weight, or the pre-degas weight. You should have about 1 gram more than your assembly weight. Again, you are going to record this value. And again, I tend to ignore the very last value and round to 3 decimal places because of a little bit of fluctuation from like air currents and static and that sort of thing. We're going to repeat that with all of the samples that you have to test. We have 6 test tubes that you can use at once in 6 locations on the degasser. we have 3 spots on the machine that you can do at once. So if you have a really long test, you probably wouldn't want to prep more than 3 at a time. If you're doing short tests such as surface area or small regions, you can prep 3 or 6 or anywhere in between that. Once you have all of your material weighed out, what you're going to do is you're going to come back to the flow degasser. First thing we're going to do is we're going to turn on the nitrogen tank right here. That's going to be via the top knob right here. The rightmost gauge reads how much is in the tank. The leftmost gauge reads the pressure that's coming to the machine here, to the flow degasser. If you notice that the right valve is reading 500 psi or less, please let lab staff know so that we can order a new one and we don't run out of nitrogen on you. To install these test tubes, what we're going to do is we're going to turn on the gas flow to one of these 6 positions right here. It's worthwhile to note that all of these are mechanical switches. So whether the flow degasser is turned on or turned off, these will flow gas by being turned on or off. So turned on right here, we've got gas flowing. I'm going to grab the straw for this one, take the cork off of the test tube, and I'm going to put the straw all the way down into the test tube so that it rests all the way on the bottom. That means that we're going to have a single direction of gas flow rather than having some sort of turbulent cycle going on down in here. So we're just going to have the gas flowing directly out. There's no direction for it to go down. We're going to very gently place the cork in the top. What that's going to do for us is close this opening here so that we don't have the potential of gas going back into the test tube. We really only have that unidirectional flow. And then I'm going to set this into the heating portion of the flow degasser. I'm also going to put one of these little, they're called Isothermal Jackets. This is one version of an isothermal jacket that you'll see in the 3-flex. This one is the hot isothermal jacket. The other one is for cold on the machine itself. What we're going to do is we're going to set this over the test tube like this, which will allow you to allow the furnace basically to be a little more efficient in heating up the whole bottom portion of your test tube. So I'm going to do that with a second test tube. Turn on the gas flow. Always make sure to turn on the gas flow first. Put the straw all the way down until it hits the bottom. Gently place the cork in top. This does not need to be forced down, and it should not be creating a seal. We are just gently pressing it in the top to kind of hold the straw in place and to narrow this opening. I'm going to set my test tube in the heating zone, and I'm going to put one of our isothermal jackets over top of it. So with all of my samples now prepped to go in the flow prep, what I'm going to do is I'm going to reach around the right side, kind of down toward the bottom, and I'm going to turn on, there's a little teeter-totter switch, I'm going to turn on the furnace. So with that switch, we have a window right here, or a screen right here, which will allow us to set the temperature. This screen on the top right kind of section in the heating zone of the flow degasser, this is going to help us set the temperature. What we will often do is do just a little bit over 100 as our set temperature. That's this green one. This red one shows the active temperature of the furnace at this moment. So when I first turned it on, it was around room temperature, 20 or so C, and it's slowly heating up so that we can get to this 150. To adjust your target temperature, you can press the up and the down arrows. And we typically like to see a little over 100 if possible. This is going to help push out any water vapor that might be absorbed into your material or stuck on the surface. And it's also going to work a little more efficiently. This can go up to 400 degrees Celsius. If you have spherical pores, it is recommended to hold for several hours below 100 degrees Celsius so that the evaporation or the rapid evaporation of your water does not potentially break or damage the pores on your surface. So if you know that you have spherical pores or some sort of non-cylindrical pore in your sample, it's recommended to start at like 80 or 90 C, hold it there for several hours, and then ramp up to a little above 100 or well above 100, whichever you're best with. If we don't know anything about the sample, what we will usually do is hold it 105 or 110 degrees overnight. So we'll do a really long hold, but a fairly low temperature. That tends to be the safest, but still be effective. It's best if you know at least a little bit about your material so that you can get a proper degassing. It is possible to do a vacuum degassing, as many machines have. Talk to lab staff if you are interested in doing vacuum degassing in addition to flow degassing for samples that tend to adsorb nitrogen even at elevated temperatures. While your samples are drying, it's a good idea to come to the computer and open up the software and get your sample files set up. The software is called 3Flex. It is both on the taskbar and on the desktop. It will first start by creating a communications link with the instrument, and then we can start by setting up your sample. So a sample file contains all of the parameters that you're going to run, and then once you've run the test, it contains all of the data. So it's kind of everything all together, the method and the results. There are a lot of preloaded methods on this instrument that follow a lot of standard kind of test types that you can do, such as BET, surface area, full isotherm for microporous materials, that sort of thing. If you want to create your own methods, go to File, New Method, and it will open up this sort of wizard here. And this wizard will allow you to tell the software about your sample. Is it an MOF? Is it a zeolite? Is it an oxide with a lot of surface area or maybe low surface area? And you can kind of talk about what type of material you have, and then tell it what you're interested in learning about your material. And then when you click Finish, it will put together this method file right here that has all of the analysis conditions and the reports that you might need. Most of the time, one of our pre-loaded or default methods is going to be enough for you. So you're going to go File, and you're going to create New Sample. This is going to open up a very similar looking window right here. This allows you to choose the method right here, and you can see a whole bunch of already kind of predetermined methods right here. The most common for us being the 5-point BET. This does data points from about 5% to 30% pressure. The other ones you can see are based on various ASTM standards. There's some low surface area BET, and you can choose whatever kind of works best for your material. These are going to range in length from maybe an hour or two to several days, so make sure that you understand what analysis is going to look like or what analysis conditions you have. In this case, we're just going to do a 5-point BET. Once I've selected that, you can look at the Analysis Conditions tab, and you can see we've got data points that it's going to collect. So these are starting at pressure and ending pressure. I have actually 5 data points: 0.05, 0.11, 0.17, 0.23, and 0.3. So those are the 5 data points it's going to collect. Under Report Options, it has given me a summary, an isotherm, and BET reports. So that's the data it's going to give me at the end. Because it's already set up this way, it does not have to do, I don't have to do any of the analysis or report setup, and I can just type in the things on this page. So I'm going to type in my sample name, the operator, and if you're running this yourself, the submitter is not going to be important to you. This is mostly if you submit samples to us for our lab staff to run. We like to keep track of who runs what. Then what we're going to do is we're going to type in the weight of the empty tube, which tends to be 39 to 40 grams. And in the sample plus tube region, we are going to type in the dry weight. Do not type in the wet weight, type in the dry weight, and hopefully you did see a little bit of a decrease in that dry weight. Once this is all set up, you're going to click Save As and choose a location to save. Right here we have user data pinned. This is the lab, has this network location right here. Under this network location, we have a folder for every one of our instruments. So any one of our instruments that is connected to the internet is connected to this network. So we've got the 3-flex right here. We have manuals, which you can read through, as well as user data. This is where everyone saves their data from this instrument. So you can create a new folder for yourself. And give your sample a sample name. Make sure to save it inside the right folder and click Save. After the period of time that you want to dry everything, you want to turn off the furnace around the back and move your test tube to the cooling section. Once it's been there long enough that you can touch the bottom without burning your hands, you may remove the gas. At this point, you would turn off the flow of the gas. Please make sure, because there's probably going to be some powder on the straw, make sure to clean the straw with a Kim wipe and some alcohol. And then head to the scale to measure your dry weight. When you get to the instrument, it will most likely look like this. What we're going to do is attach our dry weight tubes. We're going to attach them to the 3 ports here. The numbering of the ports is from left to right, 1, 2, and 3. So 1 is in the back corner, 2 is in the front middle, and then 3 is around the back side here. So what we're going to do is remove the shield. And you can either set that on the floor or on top of the instrument. We're also going to move the Doer out of the way so that we have a nice free area to work with. So we've got our free 1, 2, and 3 ports right here. Number 2 is the only one good for micropores. For surface area, we can do 1, 2, or 3, same but for mesopores. So what we're going to do is we're going to attach our test tubes to one of these 3 slots here. The first thing I'm going to do is pull out a filler rod. And I'm going to take out the cork and put in the filler rod, and that just sits right in the top here. That makes it so that this region right here is not measured, basically. We don't have to worry about that extra air. Next thing I'm going to do is put an Isothermal Jacket onto the test tube. Then I'm going to empty the port of this little, we've got this spacer or this kind of stopper right here. So I'm just going to turn the nut and pull that off. I'm going to set the stopper off to the side. And you'll see 3 pieces: the threaded nut, the ferrule, and the O-ring. And those go in that order: nut, ferrule, and O-ring. I'm also going to grab the black topper piece, and you can see there's a T right here, T for top, and that T goes in front as well, so that'll be positioned like this. What I'm going to do is I'm going to put this hole over my sample because I want to put my sample on test tube location number 1. I'm going to put that on. Then I'm going to put this assembly over all of it. And I'm just going to push the O-ring down slightly onto the test tube. I don't want to pull it all the way down. I want to keep it up fairly high, just enough that it's kind of sitting on the test tube. Then I'm going to push up like this. And I'm not going to put a lot of pressure here, just enough to kind of support it to keep it from falling, but not a lot of upward force. And then with my other hand, I am going to tighten the nut as tight as I am able. job, if you pinch here and pull, your fingers should slip before the test tube does. Now I'm going to do that with my second test tube. So I am going to take one of these glass filler rods right here, and you can see it has a little thing where it's going to hang onto the top of the test tube. I'm going to remove the cork. I'm going to place this inside. Then I am going to place this isothermal jacket over everything. And I'm going to place it with these slits down. And I'm going to set it off to the side. I'm going to remove the nut. I'm going to set this off to the side, this stopper. This has three parts, the nut, the ferrule, and the O-ring. And they go in this order. I'm going to take my test tube. I'm going to put it up through the hole right here. Then I'm going to place the nut, the ferrule, and the O-ring. Push it up. Make sure you don't have too much upward force. Just gently hold it. And then with the other hand, I'm going to tighten that in pretty much as tight as you can go. If it is in properly, when you pinch it, your fingers should slip before the test tube does. Last thing we're going to do is bring in this P0 tube, and we're going to slide it in the slit right here. Then you fill up your Doer. To fill up the liquid nitrogen Doer on the 3-flex, what you're going to do is come over to the liquid nitrogen tank that sits by the door of the room. Make sure that you put on all of the safety gear, including the blue cryo gloves and the face mask. Grab one of the Doers on the floor next to the liquid nitrogen tank. If the tank is too tall, you may need to prop the Doer up on a box like this so that the straw can reach far enough down inside. Lift the lid off. Just lift straight off. Place the straw inside. Then you're going to rotate the handle up at the top. At first you want to rotate really slowly. And you'll start to hear air coming out. It'll eventually get quieter, at which point it is filling up with liquid nitrogen. Both this Doer and the Doer on the 3-flex are 4-liter Doers. So you'll need to fill this up until you start to see drops of nitrogen coming around, of liquid nitrogen coming around the top surface. You might also have to fill this Doer 1.5 or 2 times in order to fully fill the liquid nitrogen Doer on the 3-flex. Fill this up. Until the liquid nitrogen reaches between these two areas here. install the Doer by very gently sliding it into place. The space right here is extremely close, so please make sure to keep it down low up against the bumper down at the bottom. You want to rotate it so that the M is toward the front and this handle is toward the back corner. And finally, you'll put the shield on. The shield has hooks and a space right here for the P02. That will go in here and it will hook onto silver rods on the back and either side. Once you have created all the sample files that you want, and you can create as many as you have samples, you can create everything in advance. When you're ready to run and you have your samples loaded on the machine, what you're going to do is go to Unit 1 and click on Sample Analysis, this very first one. You can see there are 3 spots, 1, 2, and 3. Those are for the 1, 2, and 3 ports, 1 being on the left, 2 being in the middle, 3 being on the right. So what I'm going to do is I'm going to click Browse on location number 1, that's where my first test tube is. And I'm going to load the sample, and you'll see this information here. If you need to edit, for example, you got a different weight than you had earlier and you need to change that, you can do that here. I'm going to do the same thing on position number 3, because that's where my other sample is. Once this is all set up, we're just going to hit Start. It'll tell you that it is not doing an in-situ degas. If you do need in-situ or vacuum degassing, please talk to staff. They can show you how to do that. Properly position the isothermal jackets, the Doer lid, and the Doer, and then click Next to start. Since this is just a BET test, this is going to be relatively quick, usually about an hour and a half for a surface area 5-point test. The machine can go up to 90 hours unattended, at which point you would need to refill the liquid nitrogen. On this screen, you'll be able to see the test as it completes. You'll be able to see any errors that pop up, and you'll be able to see the data points as they collect. When the test is finished, you will see the lines here on the graph. We've got pressure on the x-axis, and on the y-axis we've got quantity absorbed. You'll see different colors for the different ports here. To export the data, you click on whatever port you want to look at. So I'm going to click on port 1 here. You can see the tabs for the different reports that were selected in the sample file. And on the right side, you can click Save As to save as various report file types. You've got report file, Excel, XML, Unicode text, or PDF. You can save as one or multiple of those. The report file is only readable in Micromeritics software, so the 3Flex software here on the computer. The other types you can take home and read on your own. So save whatever file types you need, and then go ahead and close that out. Save all 3 of your scans if you did 3 or as many samples as you ran. Save all of those, and then you can close out of this. If you need to come back well after your tests have been run and you need to export your data, you can go up to the top and click on Reports and click Start Report. That will allow you to search for a sample file, which you can then load. Choose which reports it shows. Automatically selected will be the ones that were designated in the sample file, but you can select other reports as well. And then you can get this same report, and over on the right side you can click Save As and Export as Excel, PDF, text file, etc. Once the test is finished, the Doer will lower, and you can remove all of the pieces from the 3Flex. So you'll move this out. Going to loosen this top part. Make sure to set your test tube in the rack since it is liable to tip over. You're going to remove the lid Remove the isothermal jacket. Remove the filler rod. Make sure to put it all back into the bags or holders. Set the test tube with its cork back into the holder, and then screw this back into its spot. If there's liquid nitrogen in the Doer, you can just leave it to boil off. To clean out your test tube, make sure you're working over a Kim wipe so that you have protection against spills. We're going to return as much of the material as we are able into the container where it came from. You can see it's mostly clean through here. Some materials will stick quite a bit. If that is the case, you might want to rinse it out and catch the rinse waste so that you're not dumping your material down the drain. If your material is safe to go down the drain, you're welcome to rinse it just in the drain. Otherwise, ask staff for a receptacle to catch whatever, chemical-y stuff you have. Once you have the majority of your material out of the test tube, you're going to come to the sink. And we are going to scrub it with just a little bit of soapy water here. Put a little bit of soap in there, and right behind the sink is a big long kind of tube cleaner. I'm just going to stick that in, and we're just going to scrub it around. Make sure especially to get the bottom clean, since you're going to get stuff kind of stuck up in here. You've gone up and down a couple times. We're going to rinse this until there are no more bubbles. Alright, once we see we've got no more soap bubbles in here, we will do one last rinse with acetone. using a bottle of acetone. I'm just going to spray down the sides, and I'm going to slowly rotate so that it kind of rinses down all of the sides. This is going to help dissolve any leftover soap that might be in there. And you don't need a ton. I'm just going to give it a quick rinse there. Then drain the acetone into a Kim wipe. Do not dump it down the drain. And you can use the Kim wipe to wipe the outside of our test tube here. To clean the cork, use a little bit of ethyl alcohol. And just wipe. There should hopefully not be any powder on it, but just kind of wipe what might be on there off. And then set that in the container. For the test tube that's now clean, we're going to place it in the rack upside down, just to allow it to drip dry, and then return the rack back next to the flow degasser.